Hello everyone. This is a video on how to complete the inheritance blood typing problems. So as you can see here, I am starting on the stream page of Google Classroom. I'm going to click on classwork and then I'm going to find where it says human blood typing case files. This is a ClassKick assignment. So you're going to want to click on it. Once you click on it, it's going to ask you for your name. And then you're gonna get go. Okay. I'm gonna read each of the problems to you and give you a little bit of an idea of how to set it up. And then sometimes I will do part of it or I might just leave it blank for you to complete. Okay. So here it says human blood typing case files. Instructions. Use your knowledge of blood types and Punnett squares to solve the following problems. Explain your answers in 1 to 2 complete sentences. Case file 1. I'm going to highlight and annotate, which I recommend doing, but you don't have to do it. But remember, your highlighting tool is right here, the pen tool is here, and then the select mode to write in the text box your answer is going to be right here. So let me go ahead and start off by highlighting some of the key information. A woman's blood is left at the crime scene. After running tests to determine the blood type, it is found that she has A blood. What 2 possible genotypes or combinations of genes could the woman have? Okay, so this one I'm not going to need to write a Punnett square. I just have to know the 2 combinations of genes that will give me A blood. So remember, we can have A blood, B blood, AB blood, and O blood. So if the woman has A blood, then her 2 possible genotypes are, and I'm going to let you finish the rest of this, but I will say she can have AA or AO blood. So the A and the A are going to give A blood, and an A and an O is going to give A blood. So I do want complete sentences, and you can use this as a start to complete number 1. Moving on to number 2, hitting that next arrow there, I'm going to read and highlight this next question and find the important information. Suspect 1 has a genotype, so they have an A and an O gene. Suspect 2 has a genotype of AB, so they have one A gene and one B gene. After running tests on the blood from the murder weapon, blood type A was identified. Which suspect is more likely to be at the crime scene? How do you know? Okay, and like we saw from our other question here, I'm going to write this additional information to help us answer this question. So this is the phenotype. So that's the type of blood that she has, or that the suspect, blood type A is the phenotype. So that was the blood left at the crime scene. And remember, the genes that we can have to produce that are AA or AO. Okay, so I would say that, so this is the genotype. So what I'm looking for now is which one of the suspects has one of these 2 genotypes and matches the crime scene. Okay, so you can see here that one of these suspects does have an A blood type because they have either the AO gene or the AA gene. So once you figure that out, you can write suspect, I'm going to leave it blank, was most likely at the crime scene because their genotype of matches the blood at the crime scene. Make sure you fill in these areas here for credit on this question. So moving on now to case file 3, I will go ahead and set this up and work you through what some of this means. But I'm not going to give you the answer. You're going to have to do the thinking about that for yourself. So let's go ahead and get started. So a woman with AB blood type, all right, so she has an A and a B gene, mates with a man with a BO blood genotype. So he has a B and an O gene. What is the probability that they have a child with A blood type? So probability, this is extra information, and just in case you didn't get it, this is a percent chance, percentage chance, and it is a number from 0% to 100%. Okay, so anytime it asks you for a percentage or for a probability, we're thinking in terms of numbers. 0% meaning it's not found at all in the Punnett square, to 100% it's found in every single square. Remember, our Punnett square is like a dollar, meaning that each one of these squares is 25 or 1/4 of the entire whole. So if you find the genotype is in 1 square, that's going to be 25%. If it's in 2, it's going to be 50, and if it's in 3, it's 75%, and if it's in all 4, then it's 100%. So for this question, you are going to need to fill in your Punnett square, and I will set it up for you. So you have A and B, and then you have B and O. And the only other thing I want to remind you of is that if we have an A blood type, that means we are either looking for an A and an O gene combination, or we're looking for an A and an A gene combination. So both of these are going to give the blood type of A. So I'll just move that there, boom. So A blood type, we're looking for AA genes or an A and an O. All right, so if I go ahead and start to do this Punnett square, I'll show you for a few of them. Boom. I move each one of the parent's genes into one of the squares because that is the only place where, because only a parent can only give one of its genes here. All right. So in this first box, we have AB, one A from mom, one B from dad. And in the second box, we have BB, a B gene from mom, and a B gene from dad. You can fill in the rest. You're looking for either AA or AO. And if you have more than one, you're going to tell me the percentage down here. Okay, so you're going to be saying something like there is a chance that these two parents will have a child with A blood. All right, and again, I'm looking for a number right here. Okay, moving on to problem 4. It's another Punnett square problem. I will highlight and set it up, and then I will let you do it. So it says a parent with OO blood type. So we have here OO, 2 O genes, mates with a person who has BO blood type. And then again, we're looking for the probability that they will have a child with A blood type. Okay, so if we remember for A blood, we need either AA genes or we need an A and an O gene. Those are the two combinations that we are looking for. Alrighty. So I'll set up the square and then I'll let you guys fill in the rest. Okay, so let's take a look here. So that's for the A blood type. Those are what we're looking for. Alright, so moving down. So I'm going to go ahead and put in the first parent's genes. So we're going to have an O and an O, so they can give their child an O gene. And then the other parent can give one B gene and one O gene. Fill out the Punnett square, and then again, I'm looking for a percentage here. So I go ahead and click on the select mode, and I would say there is a chance that these two parents can have a child with O blood because, and tell me why you got that number. Alrighty, moving on to problem number 5, and I do recommend to stop and do the problem and then move on. Okay, so a man with A blood type, okay, so he has 2 A genes, has 3 children. His first child has AO, his second child has OO, and his last child has AB. Okay, his wife has BO blood, and the question is, which child is not his? How do you know? So to set this one up, I'm going to go ahead and get my pen. You do not have to do different colors. I just like to do it here. So I'm going to split his genes up. So I'm going to give him 1A here, 1A here. Okay, and then we need the mom. So the mom can give either a B or an O. Okay, what I will tell you is I'm going to put the children's genes here. We'll do kids genes. So the first one has, what did we say? A and an O gene. The second one has an O and an O. And the third one has an A and a B. So you're looking for which of these kids is not in your Punnett square, which combination of genes. Down below, you're going to write the whichever child is either 1, 2, or 3. And then you're going to tell me why. Okay. Moving right along to the next problem. Okay. A violent crime was, okay, so this is the last one. Cool. I'm just making sure. Okay. So this is the last one. A violent crime was committed at the house of a woman with the unknown blood genotype. Her first child has AB blood. Okay, so we have more children in here. The second child has AO. Okay. Her husband's blood genotype is BO. The crime scene investigators find AA blood at the crime scene. What was it the mother's? How do you know? So what we're going to do is we're going to take the father, because we know his blood genotype. He has 2 genes. He has a B and an O. Okay, and this one we don't know, but it was found at the crime scene. But we just want to know if it could be the mom's. And how we would know that is if we do the Punnett square, and if those gene combinations result in their 2 children, so they would have to produce, in order for that to be the mom's blood, it would have to produce the kids' genotypes. or the kid's genes, which are the first one, child 1 has a B, has an A and a B gene, and child 2 has an A and an O gene. So if you do this cross, then you would say either yes or no here. Is the mother, you can say blank, yes or no, yes or no, this is the mother's blood because, and then you're going to tell me why it is or it is not that the mom's blood. All right, so I hope that this video is helpful to complete this assignment, and I will see you in class.